Fluid mechanics is that branch of science that is concerned with the mechanics of fluids and the forces on them. It has applications in a wide range of disciplines, including mechanical, aerospace, civil, chemical, and biomedical engineering, geophysics, oceanography, meteorology, astrophysics, and biology. However, we restrict our topic to the flow of incompressible fluids like liquids. Further, the discussion is limited to streamline flow and turbulent flow. When a fluid flows steadily, the velocity at every point of it remains unchanged in magnitude and direction. Suppose water is flowing through a tube and the velocities of water at points A, B and C are respectively V1, V2 and V3. If the velocities at those points remain unchanged in magnitude and directions, as long as the liquid flows, then the flow of the liquid will be called steady flow. Steady flow is also called orderly flow or streamline flow, in which the liquid molecules are considered to travel along parallel lines following the shape of the tube or vessel in which they are moving. Thus, in a cylindrical tube of uniform cross-section, the streamlines are all parallel to the axis of the cylinder. It is to be noted that the flow of a fluid is streamlined when the flow velocity is low. If the flow velocity is increased beyond a critical value known as critical velocity, eddy currents and sideways movement of the molecules occur and turbulence sets in. In this condition, the velocity of different fluid particles always changes in magnitude as well as in direction. This type of flow is called turbulent flow. Streamline or turbulent flow can be displayed very easily in the following way. Suppose water is flowing through a narrow tube of uniform bore and there is an arrangement for increasing the velocity of water flow slowly. If any colored matter like potassium permanganate or indigo is held at the mouth where water enters the tube, then as long as the velocity of water is below the critical value, the colored liquid stays near the central axis as it flows along, showing that the flow is streamlined. But if the velocity of water increases to nearly the critical velocity, it becomes wavy, showing that the flow is turning out to be turbulent. Finally, when the velocity of water exceeds the critical velocity, the colored liquid spreads over the whole cross-section, suggesting that the flow is no longer steady but is turbulent.